Hey dreamers, you're just in time for some chill science. Tonight we're diving into evolution's sneaky ways of, well, deleting the scariest predators so humans could take over. No jump scares, no stress, just cozy facts to unwind with. So grab a blanket, hit subscribe if you're new here, and let your brain drift into sleepy science mode. Megalodon, the shark that ruled our oceans. For 20 million years, the oceans belonged to one creature, a predator so perfectly designed for killing that it makes today's great white sharks look like goldfish. This was Otodus megalodon, the ultimate shark that grew up to 60 feet long, the length of a semi-truck, with jaws capable of crushing a small car. Fossil evidence shows this wasn't just a big fish. It was nature's most efficient murder machine, specializing in ripping whales in half with its 7-inch serrated teeth. Megalodon thrived during the Miocene and Pliocene epochs, from about 23 to 3.6 million years ago. While dinosaurs had been gone for over 40 million years, Megalodon shared the planet with early human ancestors, though thankfully not in the same waters. Its territory spanned the entire globe, with fossil teeth found on every continent except Antarctica. The shark's hunting strategy was brutally effective. First, a devastating upward strike to immobilize prey by crushing fins or tails, followed by targeted bites to puncture lungs and rupture vital organs. Whale fossils from this period often show distinctive crescent-shaped wounds matching Megalodon's tooth arrangement, proof it regularly fed on creatures the size of school buses. We should send thank you cards to the universe for wiping out Megalodon. When the Isthmus of Panama formed 3 million years ago, it triggered catastrophic climate changes. Ocean currents shifted, cooling the seas and destroying the shallow coastal nurseries where Megalodon pups grew. Its primary food source, slow-moving fatty whales, either went extinct or evolved to swim faster in colder waters. Smaller, more adaptable predators like great white sharks began outcompeting the giant. Then, around 2.6 million years ago, a potential supernova may have bombarded Earth with cosmic radiation, further disrupting marine ecosystems. The perfect storm of events eradicated history's greatest shark. Could Megalodon return? Despite sensational documentaries, marine biologists confirm it's impossible. Modern oceans lack the warm, oxygen-rich conditions and abundant mega-prey that sustained these giants. Even if one somehow survived, our sonar-equipped fishing fleets would have detected it. However, scientists have discovered that great white sharks retain about 15% of Megalodon's genetic blueprint, a haunting reminder of what once ruled the deep. The Megalodon's legacy lives on in the 250-plus fossil teeth, still found annually, each one a snapshot of when Earth's oceans were truly terrifying. Its extinction allowed marine mammals to flourish and ultimately made human exploration of the seas possible. Next time you swim in the ocean, remember, we only enjoy that privilege because this monster no longer patrols the depths. Titanoboa, the nightmare snake that ruled the jungle. 60 million years ago, in the steamy swamps of prehistoric Colombia, a predator slithered through the water that would make today's anacondas look like garden snakes. Titanoboa ceratomermex, the largest snake to ever exist, stretched over 42 feet long and weighed more than a pickup truck. With a body thicker than a telephone pole and crushing force exceeding 400 pounds per square inch, this serpent could swallow a full-grown cow whole before digesting it for months. Titanoboa thrived during the Paleocene epoch, just 5 million years after the dinosaurs went extinct. At this time, Earth's average temperature was nearly 10 degrees Fahrenheit hotter than today, creating vast tropical wetlands across South America. Scientists discovered its fossils in Colombia's Cerrejón coal mine, where the snake's vertebrae, each the size of a grapefruit, lay alongside fossils of giant turtles and crocodilians it preyed upon. Unlike modern constrictors that ambush prey, Titanoboa likely hunted like a submarine. Its eyes and nostrils positioned atop its head, allowing it to stalk from below the water's surface before striking with terrifying speed. The extinction of Titanoboa came as Earth's climate gradually cooled. As rainforests shrank and fragmented into smaller pockets, the massive snake couldn't adapt to the changing ecosystem. Its cold-blooded metabolism required constant warmth. When global temperatures dropped even slightly, Titanoboa's enormous body became a liability rather than an advantage. Smaller snakes like ancestral boas and pythons survived by being more energy efficient, eventually evolving into the species we know today. Humanity owes Titanoboa's extinction a huge thank you note. Modern tropical ecosystems simply couldn't support such an apex predator. A single Titanoboa would require prey equivalent to several deer or wild pigs each month, devastating local livestock and potentially viewing humans as suitable meals. Even more terrifying, fossil evidence suggests these snakes may have been semi-aquatic, meaning they could have haunted rivers and lakes across multiple continents if they'd survived. Could Titanoboa return? Unlike shark species that retain ancient DNA, no living snake carries enough of Titanoboa's genetic blueprint for de-extinction. Even if scientists attempted to recreate it, today's cooler climate couldn't sustain such a massive reptile outside controlled environments. However, climate change presents an eerie possibility. As global temperatures rise, some scientists speculate that tropical species may gradually grow larger, following a biological principle called Bergmann's rule. While we'll never see a true Titanoboa again, its legacy lives on in our fascination with monster snakes and the very real lesson that Earth once hosted creatures beyond our wildest nightmares. The next time you watch a jungle documentary, remember, the shadows beneath those murky waters were once home to a predator so perfectly adapted to its environment that nothing could challenge its reign, until the planet itself decided the age of giant snakes was over. Quetzalcoatlus, the sky tyrant that made dinosaurs look up in terror. Imagine a flying predator so massive its shadow could blot out the sun over an entire football field. Quetzalcoatlus northropi, named after the Aztec feathered serpent god, wasn't just the largest flying creature to ever exist, it was nature's most terrifying drone, with a 33-foot, 10-meter wingspan that dwarfed modern condors. When this pterosaur soared over late Cretaceous North America 68 million years ago, even tyrannosaurs would have scrambled for cover beneath the trees. This aerial monster defied everything we know about flight physics. Standing 18 feet tall, as high as a giraffe, with a 10-foot-long skull and spear-like beak, Quetzalcoatlus weighed only about 550 pounds thanks to hollow ultralight bones. Paleontologists still debate how it launched itself into the air, with the most plausible theory suggesting it used its powerful forelimbs to vault upward like a macabre pole vaulter before catching thermal updrafts. Once airborne, it could cruise at speeds of 80 miles per hour for thousands of miles without landing, essentially functioning as a living fighter jet. Quetzalcoatlus's hunting strategy remains one of paleontology's most chilling mysteries. Unlike smaller pterosaurs that caught fish, its anatomy suggests it stalked prey on foot like a monstrous stork, using its razor-sharp beak to impale baby dinosaurs or tear chunks from carcasses. Fossil evidence from Texas shows it shared its habitat with titanosaurs, meaning it might have harassed juveniles of these 70-ton herbivores, pecking at their eyes and flanks until they collapsed from exhaustion or infection. The asteroid that wiped out the dinosaurs 66 million years ago also grounded Quetzalcoatlus forever. As the impact winter destroyed global ecosystems, these enormous flyers faced a triple threat. Their massive size required constant food intake, their slow reproductive rate prevented quick adaptation, and their specialized hunting techniques became useless in the barren post-apocalyptic landscape. Within decades, the skies were empty of their shadows. Humanity should send cosmic thank you notes for this extinction. A modern Quetzalcoatlus would render air travel hazardous. Imagine one colliding with a 737. Their territorial nature would make open-air stadiums and skyscrapers perpetual danger zones. Even more terrifying, their possible intelligence. Pterosaur brains show advanced problem-solving regions, suggesting Quetzalcoatlus might have learned to exploit human settlements for food. Could this sky tyrant return? Geneticists confirm it's impossible. No living species carries enough of its DNA, and artificial recreation would require solving biomechanical puzzles even our best engineers can't crack. However, climate change is causing some bird species to evolve larger body sizes. While we'll never see a true Quetzalcoatlus again, its legacy lives on in our nightmares, and in the way every large shadow from a passing plane still triggers some primal fear of being snatched from below. The next time you watch an eagle soar, remember, 68 million years ago, its distant relative ruled the skies with such terrifying efficiency that it made the ground, not the air, the safest place to be. Deinonychus, the real Jurassic Park raptor that was scarier than fiction. The velociraptors from Jurassic Park that haunted your childhood nightmares, they were actually scaled-down, dumbed-down versions of a far more terrifying predator. Meet Deinonychus anteropus, the real-life raptor that stood 5 feet tall, weighed 160 pounds, and hunted in coordinated packs with the strategic brilliance of modern wolves. This Utahraptor-sized killer roamed North America 115 to 108 million years ago during the Cretaceous period, leaving behind fossil evidence that rewrote our understanding of dinosaur intelligence. Unlike the solitary reptilian movie monsters, Deinonychus displayed frighteningly advanced behaviors. CT scans of its skull reveal a brain-to-body ratio comparable to some modern birds, with enlarged optic lobes suggesting binocular vision perfect for judging distances during high-speed attacks. Its signature 5-inch sickle claw wasn't just for slashing. Biomechanical studies show it functioned like a climbing crampon, allowing the raptor to leap onto prey and cling while delivering precise bites with 60 blade-like teeth. Fossilized trackways in Montana preserve the moment a Deinonychus pack surrounded a Tenontosaurus, their coordinated attack preserved in mudstone for eternity. The hunting strategy of Deinonychus would make military tacticians envious. Paleontologists analyzing bite marks on prey bones found repetitive patterns, evidence they systematically weaken targets by attacking tendons and arteries first. Their lightweight skeletons and stiff counterbalancing tails made them agile at speeds up to 25 miles per hour, while their feathered insulation allowed nocturnal hunts when larger predators slept. This wasn't just a predator, it was nature's perfect commando unit. Deinonychus vanished during the Cenomanian Age, millions of years before the asteroid impact, likely due to shifting climates that disrupted its preferred forest edge habitats. As flowering plants transformed ecosystems, its prey either migrated or grew too large for even packs to tackle. The KT extinction that finished off T. rex simply ensured no successors could reclaim its niche. Humanity dodged an evolutionary bullet with this extinction. A modern Deinonychus population would render hiking trails, farms, and even suburban areas perilous. Their problem-solving skills, evidenced by fossilized nesting sites showing complex parental care, suggest they might have learned to open doors or exploit human infrastructure. Even more chilling, their descendants never truly disappeared. Modern birds, from hawks to cassowaries, carry fragments of their deadly legacy. Could Deinonychus return? While its DNA is too degraded for Jurassic Park-style resurrection, scientists have identified the specific genes that gave it such lethal claws in chicken embryos. Thankfully, ethical barriers prevent creating chicken-soar hybrids, but the very possibility proves how close this nightmare remains in evolutionary terms. Climate change could theoretically favor the re-emergence of similar pack hunting strategies in large birds, though none would match the original's terrifying combination of size and intelligence. The next time you hear crows coordinating a mob attack on an owl, remember, their distant cousin was the reason many dinosaurs slept with one eye open. Deinonychus wasn't just a predator, it was proof that evolution sometimes engineers perfect killers, then mercifully shelves the blueprint. Gigantopithecus, the real King Kong that nature wisely retired. Deep in the Pleistocene forests of Southeast Asia, between 2 million and 300,000 years ago, our ancestors shared their world with a primate that would make a silverback gorilla look like a house cat. Gigantopithecus black eye stood 10 feet tall, 3 meters, and weighed over 1,100 pounds, the largest ape to ever walk the earth. Fossilized teeth the size of baseballs and jawbones thicker than bricks tell the story of a creature that could peel bamboo stalks like bananas and likely terrified early humans with its thunderous chest-beating displays. This mega-ape occupied the same evolutionary neighborhood as us, coexisting with Homo erectus in what's now China, India, and Vietnam. Unlike the fictional Kong who scaled skyscrapers, real Gigantopithecus was probably too heavy to climb trees, instead knuckle-walking through dense forests on palms the size of dinner plates. Analysis of tooth enamel shows it followed a strict vegetarian diet, but don't mistake this for gentleness. Modern gorillas demonstrate how powerful herbivores can be, and a 1,100-pound ape would have viewed humans as potential threats to its territory. Cave sites where Gigantopithecus and early human fossils overlap suggest uneasy coexistence at best. The extinction of Gigantopithecus around 300,000 years ago reveals a cautionary tale about climate change. As Pleistocene forests gave way to grasslands during a drying period, this specialist feeder couldn't adapt its bamboo-heavy diet. Its massive size, once an advantage, became a liability, requiring up to 80 pounds of vegetation daily from shrinking habitats. Meanwhile, smaller, more adaptable primates like orangutans survived by being less picky eaters. Humanity should breathe a sigh of relief that Gigantopithecus disappeared when it did. A surviving population would have made the development of agriculture in Asia nearly impossible. Imagine trying to farm rice fields while fending off territorial ape giants. Their potential conflicts with humans would have dwarfed modern human-wildlife conflicts with elephants or gorillas. Even more troubling, some cryptozoologists believe unverified reports of the Yeti or Bigfoot could represent relict populations, though no credible evidence supports this. Could science bring back Gigantopithecus? Unlike Ice Age mammals preserved in permafrost, no complete DNA exists for this tropical-dwelling ape. However, scientists recently sequenced proteins from 1.9-million-year-old Gigantopithecus teeth, the first step toward understanding its genetic relationship to modern great apes. While de-extinction remains unlikely, its legacy lives on in orangutans, its closest living relatives that share 97% of our own DNA. The next time you watch a King Kong movie, remember, the truth was both less dramatic and more biologically plausible. Gigantopithecus proves that nature once experimented with supersized primates, and wisely decided that the world wasn't quite ready for 10-foot-tall, half-ton apes to share the planet with tool-using, fire-making humans. Its fossilized teeth serve as silent monuments to an evolutionary path best left in the past. Andrewsarchus, the nightmare wolf rhino that ruled prehistoric Asia. Picture the unholy union of a grizzly bear, a wolf, and a rhinoceros. That was Andrewsarchus mongoliensis, Earth's largest terrestrial mammalian predator that ever lived. This 12-foot-long, 1,800-pound monster prowled the forests and floodplains of Central Asia during the Eocene epoch, approximately 45 to 36 million years ago. With a skull nearly 3 feet long, bigger than any modern land carnivore, and bone-crushing jaws capable of generating 3,000 pounds of bite force, this creature makes today's apex predators look like house pets. Discovered in the Mongolian Gobi Desert in 1923, Andrewsarchus remains one of paleontology's greatest mysteries. Its fragmented fossils suggest a terrifying anatomy: rhino-sized body with hooved feet, a long snout resembling an oversized hyena, and teeth designed for shearing flesh and crushing bone. Unlike modern predators that specialize in either hunting or scavenging, Andrewsarchus was likely an opportunistic omnivore. Fossil evidence shows it could crunch through turtle shells as easily as it could strip meat from carcasses. Scientists believe it occupied a unique ecological niche, using its sheer bulk to steal kills from smaller predators rather than chasing down agile prey. The hunting strategy of Andrewsarchus would have been brutally efficient. Analysis of its limb proportions suggests it wasn't built for speed but for explosive bursts of power. Imagine a freight train with teeth ambushing prey at waterholes. Its hooved feet, similar to modern pigs, gave it surprising stability when wrestling struggling victims. Paleontologists speculate it may have hunted like a supersized wolverine, using its massive head as a battering ram to knock prey off balance before delivering crushing bites to the skull or spine. Andrewsarchus disappeared during the late Eocene climatic transition, when global cooling transformed its lush habitats into arid steppes. As dense forests gave way to open grasslands, this ambush predator lost both its cover and its preferred mixed diet. Smaller, more specialized carnivores like early dogs and bear dogs outcompeted the generalized Andrewsarchus. The final blow came when new migratory patterns of prey animals left this heavyweight predator without reliable food sources. Humanity should thank evolutionary fate for this extinction. A modern Andrewsarchus population would rewrite entire food chains. Its size and appetite could decimate livestock populations, while its intelligence, inferred from brain cavity scans, might make it bold enough to view human settlements as buffets. Even more terrifying, its potential omnivora means no food source from crops to garbage would be safe from its appetites. Could this monster return? While no direct descendants exist, scientists note that hippopotamuses, its closest living relatives, share some anatomical similarities. However, the genetic gap is too vast for any natural return. Climate change could theoretically favor the evolution of larger omnivorous mammals, but none would match Andrewsarchus's terrifying combination of size, strength, and adaptability. The next time you hear wolves howling in the distance, remember, their prehistoric cousin was a predator so formidable that it makes today's grizzly bears look like teddy bears. Andrewsarchus stands as proof that nature sometimes creates perfect predators, then mercifully retires the design. Its fossilized skull remains both a scientific treasure and a chilling reminder of what once ruled the ancient forests of Asia. Ceratomyrmex, the nightmare ant with a horn of horrors. Picture an ant from your worst nightmares. Not just big, but equipped with biological weapons straight out of a horror movie. Ceratomyrmex ellenbergeri, nicknamed the Hell Ant, was a prehistoric predator that ruled the Cretaceous forests 99 million years ago. Preserved in amber with its final meal still trapped in its deadly grip, this insect proves nature once experimented with hunting strategies too terrifying to survive. Unlike any modern ant, Ceratomyrmex sported a vertical, scythe-like horn protruding from its forehead, lined with sharp bristles. Its mandibles opened vertically instead of horizontally, an evolutionary quirk that turned its entire face into a snapping trap. Fossil evidence shows it used its horn to impale prey against this unique jaw arrangement, creating a nightmarish push-and-snap killing mechanism. The recently discovered amber specimen from Myanmar captures one in the act of devouring a Caputophractor elegans beetle, its horn pinning the victim while its blade-like jaws sawed through the exoskeleton. This insect lived during the golden age of dinosaurs, occupying the same humid forests as early mammals and feathered raptors. At just half an inch long, its size belied its ecological impact. Hell ants like Ceratomyrmex were likely the apex invertebrate predators of their time. Their hunting strategy combined precision and brutality. Sensitive hairs on the horn detected prey vibrations, triggering a lightning-fast strike that could harpoon even flying insects mid-air. Modern trap-jaw ants use a similar mechanism, but none possess this terrifying facial weaponry. The extinction of hell ants 65 million years ago remains partially mysterious. Unlike dinosaurs wiped out by the asteroid impact, these insects likely fell victim to the ecological collapse that followed. As forest canopies burned and global temperatures fluctuated, their specialized hunting adaptations became liabilities. Modern ants, with more versatile mandibles and social structures, outcompeted these evolutionary oddballs. The last Ceratomyrmex probably died staring at a changing world its biology couldn't handle. Humanity should thank cosmic luck that hell ants didn't survive. A modern population would make picnics literal nightmares. Imagine an ant that could spear your finger like a shish kebab. Their venom, inferred from related species, may have contained neurotoxins strong enough to cause paralysis. Even more chilling, some hell ant species showed primitive eusocial behavior, meaning they might have developed colony structures rivaling today's army ants in lethality. Could Ceratomyrmex return? Geneticists confirm it's impossible. The 99 million-year DNA gap is too vast, and no living ants carry its unique horn-building genes. However, climate change is causing some ant species to evolve unusually specialized mandibles. While we'll never see true hell ants again, their legacy lives on in the 10,000-plus ant species that still dominate our ecosystems. Proof that sometimes nature's scariest experiments get replaced by more efficient models. The next time you see an ant trail in your kitchen, remember, their prehistoric cousin was a predator so specialized that it turned its own face into a weapon. Ceratomyrmex proves that even insects once had their age of monsters, and that Earth is better off with them safely locked in amber. The Thylacine, nature's most bizarre wolf that wasn't a wolf. Imagine a predator that looked like a tiger-striped dog, could open its jaws 120 degrees like a snake, and carried its young in a pouch. Meet the Thylacine, Thylacinus cynocephalus, Australia's enigmatic Tasmanian tiger, that defied classification until its tragic extinction in 1936. This marsupial carnivore wasn't just unique, it was the last survivor of an ancient lineage that once competed with placental wolves on equal terms, evolving eerily similar features through convergent evolution. The Thylacine's most terrifying feature was its hyper-specialized skull, a biological masterpiece that combined canine appearance with reptilian capabilities. CT scans revealed jaw muscles arranged like a crocodile's, allowing it to deliver bone-crushing bites while its unusual jaw joints permitted extreme gape angles to swallow large prey whole. Unlike true wolves that hunt in packs, Thylacines were solitary ambush predators, using their distinctive tiger-like stripes as camouflage in Tasmania's grasslands before launching explosive attacks. Historical accounts describe their hunting strategy as methodical. They would trail prey for miles at a time with eerie patience before delivering a single devastating bite to the skull or spine. This evolutionary marvel met its end through human persecution. European settlers in Tasmania wrongly blamed thylacines for livestock losses. Most attacks were actually feral dogs, leading to government-sanctioned bounty hunting from 1888 to 1909 that paid £1 per adult killed, equivalent to $200 today. The last known thylacine, named Benjamin, died in Hobart Zoo on September 7, 1936, just 2 months after Tasmania finally granted the species protected status. Modern analysis shows only about 5% of Tasmania's habitat could still support thylacines by the 1930s due to human encroachment. Paradoxically, humanity both destroyed the thylacine and desperately wishes it back. Recent studies suggest its extinction created an ecological ripple effect. Without this apex predator, Tasmania's ecosystem became unbalanced, allowing invasive species like feral cats to proliferate, yet we're fortunate its range never expanded globally. A population of pouch-equipped super predators could have radically altered human settlement patterns in warm climates. Science now races against time to undo this extinction. The Thylacine genome was fully sequenced in 2017 from preserved Joey specimens, revealing it had already suffered dangerous genetic bottlenecks before European arrival. Current-day extinction efforts at the University of Melbourne use CRISPR technology to edit the DNA of its closest living relative, the mouse-sized fat-tailed dunnart. While challenges remain, particularly reconstructing gut microbiome and parenting behaviors, scientists estimate we may see proxy thylacines within a decade. The thylacine's legacy haunts conservation biology. Its story proves that unique evolutionary pathways can vanish overnight due to human ignorance, while simultaneously demonstrating how close we're getting to reversing such mistakes. The next time you see a wolf documentary, remember, Australia once had its own version that broke all mammalian rules, and we're only beginning to understand what we truly lost when Benjamin took his last breath in that cold zoo enclosure nearly a century ago. Haast's eagle, the aerial assassin that turned New Zealand into a killing field. Imagine a bird of prey so massive it could swoop down and carry off an adult deer. Hyraetus morae, known as Haast's eagle, was Earth's largest known eagle, a 40-pound feathered fighter jet with a 10-foot wingspan and talons the size of tiger claws. This evolutionary terror ruled the skies over New Zealand until just 600 years ago, specializing in hunting moa, flightless birds that weighed up to 440 pounds, 200 kilograms, and stood 12 feet tall. The hunting strategy of Haast's eagle was brutally efficient. Biomechanical studies of its skeleton reveal it didn't soar like modern eagles, but attacked in terrifying low-altitude strikes, reaching speeds of 50 miles per hour as it plunged from hidden perches. Its 3-inch-long talons, larger than those of any living raptor, could puncture moa skulls or spinal columns with surgical precision. Maori cave paintings depict these attacks, showing eagles striking from behind to avoid the moa's powerful kicking legs. Fossil evidence shows the eagles targeted juvenile moa first, their talons perfectly sized to crush the bird's pelvic bones in midair. This aerial killer existed because of New Zealand's bizarre evolutionary isolation. With no native land mammals before human arrival, birds filled all ecological niches. The eagles evolved their monstrous size to exploit the moa buffet, their weight doubling and their strength increasing tenfold over just a few million years, the fastest known evolutionary arms race between predator and prey. Haast's eagle vanished around 1445 AD shortly after Maori settlers arrived. The cause wasn't direct hunting but ecological collapse. As humans exterminated the moa, all 9 species were gone by 1500 AD. The eagles starved. Isotope analysis of eagle bones shows their diet shifted dramatically in their final years, from moa meat to smaller birds and even scavenged human food waste, a desperate attempt to survive in a changing world. Humanity narrowly avoided an ongoing nightmare with this extinction. A modern population of Haast's eagles would make outdoor activities in New Zealand impossibly dangerous. Their strike force could kill an adult human, as evidenced by Maori oral histories describing the hokioi that snatched children. Even more terrifying, these eagles may have been intelligent enough to recognize human hunting patterns, potentially viewing us as both competitors and prey. The extinction efforts face unique challenges with Haast's eagle. While its closest living relative, Australia's little eagle, weighs just 2 pounds, scientists have identified the specific genes responsible for its gigantism. Theoretical de-extinction would require both genetic engineering and reintroduction of moa-like prey, an ecological impossibility. However, climate change is causing some modern eagles to grow larger, proving the evolutionary potential still exists. The next time you see a bald eagle, remember, its New Zealand cousin was the product of an evolutionary experiment so extreme it turned birds into the equivalent of attack helicopters. Haast's eagle remains both a cautionary tale about human impact on ecosystems and a reminder that nature's most terrifying predators sometimes wear feathers rather than fur. Hallucigenia, the walking nightmare that redefined evolution. Imagine an alien life form so bizarre that scientists initially reconstructed it upside down and backward. Hallucigenia sparsa, a 1-inch-long creature from the Cambrian explosion 505 million years ago, looked like a surrealist painting come to life, a worm-like body walking on 14 pairs of needle-tipped legs topped with a row of menacing spines and crowned with a featureless head that still puzzles paleontologists. This wasn't just another extinct oddity. Its discovery in Canada's Burgess Shale fundamentally changed our understanding of how animal body plans evolved. Hallucigenia's anatomy reads like a mad scientist's sketchbook. Advanced microscopy of its fossils reveals each of its stilt-like legs ended in a pair of microscopic claws, the earliest known precursors to arthropod appendages. Its dorsal spines, once mistaken for legs, were hollow structures possibly filled with toxic compounds as defense against predators like Anomalocaris. Most perplexing is its head. Recent CT scans show a balloon-like structure with circular mouth and pharyngeal teeth, but no recognizable eyes or antennae. Some researchers speculate it may have fed by sucking up microbial mats like a living vacuum cleaner. This creature thrived during the Cambrian explosion, when life underwent its most dramatic diversification. Unlike modern ecosystems where body plans follow predictable patterns, Hallucigenia's world was an evolutionary laboratory where nature experimented wildly. Its peculiar design likely represented an early branch of the ecdysozoan lineage, the group that would eventually spawn insects, spiders, and crustaceans. Fossil evidence suggests it crawled along ancient seafloors using its legs like a conveyor belt while its spines deterred attackers, a biological tank in miniature. Hallucigenia's extinction wasn't so much an ending as an absorption. As the Cambrian gave way to the Ordovician period 485 million years ago, more efficient body plans outcompeted such experimental designs. Its genetic legacy, however, lives on in every insect that molts its exoskeleton. Hallucigenia's growth rings suggest it pioneered this process. Modern velvet worms in tropical forests carry faint echoes of its anatomy, but none match its surreal combination of features. Humanity should appreciate this creature's disappearance. If Hallucigenia-like organisms still existed, they might have preempted the evolution of vertebrates. Their potential ecological roles could have fundamentally altered food chains in ways that made human evolution impossible. Even more unsettling, some of its defensive toxins might have been precursors to complex venoms that could have made Earth's ecosystems far more dangerous. Could Hallucigenia return? Geneticists confirm it's biologically impossible. Its body plan represents a failed experiment too distant from modern DNA. However, synthetic biologists at MIT have used Hallucigenia as inspiration for designing microscopic robots that walk on chemical-sensitive legs. Its spiny defense system has even influenced new armor technologies for military drones. The next time you see a centipede, remember, its half-billion-year-old cousin was a creature so strange that it took scientists 40 years just to figure out which way was up. Hallucigenia proves that evolution's first drafts were often weirder than anything science fiction could invent. and that sometimes the most important life forms are those that left no direct descendants, only questions written in stone. Evolution is like a genius designer that tests different life forms, keeping only the most efficient ones. If mega predators like Megalodon or raptor still roamed the earth today, humanity would have been in trouble. But nature knew that for an intelligent species to thrive, it needed a safer environment. So in a way, evolution did us a favor by removing competitors we couldn't handle. And when you think about it, maybe we are evolution's newest experiment, a species that reshapes the planet. But will we do better than the dinosaurs? That's up for debate. Good night, everyone. Don't forget to like, subscribe, and hit that bell for more mind-blowing science and evolution mysteries.